Hi everyone, welcome to the 100th session of Python for Machine Learning. In this session, we will learn about the simple imputer, wherein I'll show you how to handle missing values using the mean values, median values, modal values, and the constant values. The main intention behind creating this video is my previous video, which is video number 15, handling missing values with imputer. Because at that time, if you see what I have done, I have imported imputer from sklearn.preprocessing, but that is obsolete now. Okay, so instead of that, if we want to use imputing, if we want to apply imputation on data set, we need to port like from sklearn.impute import simple imputer. So how this will be executed? If we execute this will not work, right? So because that is obsolete. Now what I will do, I will import our libraries pandas, numpy, and from sklearn.impute import simple imputer, and I will also import the diabetes dataset that I will use throughout this video. So let's start. So if you can see, this is my diabetes dataset, and if I apply df.isNull.sum, it will give me the count of my total null values in the dataset. And if I give df.shape, it will give me, I have 649 rows and 9 columns. Okay, so in the column glucose and diastolic BP, skin fold, and serum insulin and BMI, I have null values. The rest of the column does not have null values. So what I will use, I will start we'll start with my presentation, and then I will use Python to implement simple imputer. Before that, please note you can reach out to me at technologyCult@gmail.com, and my GitHub account is also mentioned here. Mean imputation, suppose we have a column like serum insulin, and in that column we have some null values. So what we will do, if we want to use the mean imputation, then we can get the mean of this 75 plus 88 plus 94 plus 168 plus 563, which will give us 193.6. And what we'll do, we will replace the NN with 193, and that's how we apply mean imputation. And how do we apply this using Python? So what we will do, we'll take a copy of this data set, okay, and like as of now, like I will not use this as a data set. I will use this as a data set in the second half of the video. So I will give you first the same example what I am using here, exactly the same data set. I will have a data frame with one column, df2 is equals to pd dot data frame, okay, and I'll give df, I'll say column name anything, okay, col is equals to, if you see here what I have, 75, 88, nan, 94, 168, nan, and 543. Then I'll give 75, 88, comma np dot nan, comma 94, comma 168, comma np dot nan, comma 543. I'll execute this. My df2 is created. So df2 is nothing but with one column and it has some rows. Now I want to apply mean imputation. So what I will do, df2 underscore mean is equals to, I will give mean underscore imputer, which is equals to simple imputer, and I'll give strategy is equals to mean, and after that I will apply df2. So I'll say df2 dot ilog, and then I'll give, which is df2 dot ilog means all the rows and all the columns. So it has only one row and one column, and my object for imputer is mean imputer dot, I will say fit underscore transform, and I'll give here df2. Now the moment I apply this, print df2. So exactly what I have shown here, my nan values is being replaced by my mean values. Now what we'll do, exactly we'll take this and then we'll give the task number 2, which is nothing but imputation with median. And please note, I am keeping the data set in a sorted order, because in median that plays a big role. What is median? How does median work? Median imputation work. In case of the median imputation, we will not consider NN. So if we remove the NN, how many rows we have that has value 1, 2, 3, 4, 5. Now if we sort these 5 values, 94 is my middle element. So that will be my median. So what happens, this NaN will be replaced by 94. That's how median imputation works. So I will show here how does it work. And what I will do, instead of this mean, I will give the strategy as median imputer. And here I will apply this on median imputer. Now if I execute this, now try to print df2. So if you see this, the value what we have 75, this NaN will be replaced by 94, right? 75, 88, 94, 75, 88, 94, 94, 168, 94, 543. See, in this case, if we remove the NaN values, we have the number of remaining records is 5. So to get the middle element is very easy. But in this case, if you see here 1, 2, 3, 4, 5, 6, there are 6 rows which is filled with values. So in this case, the middle element will be 94 and 166, right? So we get the mean of this 94 plus 166 and divide by 2, okay? The mean of these two numbers, which will be 131, and that will be my median. And then if we implement the median imputation, in this case, it will fill this with 131. How it will work, let's see. Okay, so in this case, what I'm doing here, instead of 168, I will fill this with 220. Okay, and then I'll give print df2. Now execute this. So if you see here, this initially df2 was having what did it 75, 88, and then here we had np.nan. That nan is being replaced with 131, and this is exactly what we had: 75, 88, 131, 75, 88, 131, 94, 168, 220, 543. Okay, so that's how median imputation will work. Task number 4, how the modal imputation works. Okay, I just want to show you that. If you see here, in this case, okay, there is no repetition. There are two null values in this column, and there are no repetition. In that case, the very first number will be my mode. Okay, and if you see here, this NaN, both the NaNs will be replaced by 75. So how does it work in Python? Okay, instead of this, I give mode imputer, most strategy as most frequent, and then here we will apply fit underscore transform on mode imputer. Okay, and then we'll print df2. In this case, what will happen? This, and what is the data set that we have? The data set is this one, right? We have 75, 88 NaN, 75, 88 NaN, 94, 168 NaN, and then 543. Now we'll apply here the modal imputation. Okay, so you see, wherever we have NaN, it is being replaced by 75 if there is no repetition of the number. Now what if the number is repeated? Okay, in this case, if the number is repeated, see, 94 is repeated twice, the rest of the number is being repeated once. That is my mode, and all the NaNs will be replaced by 94, as you can see in the right hand side. This will be our task number 5. This 168 will replace by 94. Okay, now if you implement this, see here, output will be 75, 88, and 94 will be repeated twice, and then 543. So that's how imputer works very simply with Python. By importing the SimpleImputer from the library, and the library is sklearn.impute. We will import the SimpleImputer. Now after this, what we'll do, see, sometimes we will not be replacing the null values with mean, median, or mode. We want to replace it with our values that will be based on the business decisions, right? So in that case, sklearn is providing us the another option, which is called the constant strategy, and wherein they will ask us to fill it with a particular value. So how it will work? See, fill value will give it as 100, suppose. Okay, and now what we will do, we will say, we will term it as constant imputer, and we'll apply that constant imputer, apply fit underscore transform. Okay, so now when we implement this, you see the NaN, the NaNs is being replaced by 100. That is based on our choice. So what we have covered is, we have covered how to fill the null values in our data set with mean values, median values. I have shown in both the cases where the number of records are even and odd. Then how to implement using modal values if there is only no repetition of the numbers, and if there is a repetition of numbers, even how to apply imputation using the constant value. Okay, now life will be is not as simple. We will not have a data set with just one column. it will have hundreds of columns when we do a real world analysis, even sometimes thousands. Okay, so in that case, how do we apply imputation on the data set? So now the real game starts. Okay, I have already imputed df is equals to, this is my diabetes data set. So if you see, my df is already there. Now here, this is my df, right? This is my data frame, which is df. Okay, and we have the null values also. So if we give df dot is null dot sum. So if we give df dot is null dot sum, it will give me the total number of missing values in each column. So what I will do, I will create a df underscore mean. What I will do, I will copy this. I don't want to touch my original data set. So df dot copy, and I'll give deep is equals to true. Deep is equal to true is basically to keep the indexes, and it's a very big topic. Deep is equals to true, I will cover in my another section, which is generally related to object with reference and object by values. After that, I'll create, now here I will copy it, and then I'll create a mean imputer, which is equals to simple Okay, so if you see here, this is my original data set, and what I am trying to do, I am trying to, df is my original data set. Okay, I am trying to take a backup in df underscore mean. I have created a mean imputer where strategy is mean, and then, so in this case, if you execute this, and after this I will try to execute this. Sorry, here it will be. Okay, so why this error is coming now? After applying this imputation, still I am getting the number of it shows the null values, because I am trying to print df, and the data set on which I am applying in the imputation is df mean underscore mean. So if I will give mean, now if I print this, so there is no null values now in my data set df underscore mean. Okay, so now similarly, what I will do, I will impute using the median values. I will impute using the strategy which is equals to mean. Strategy which will equals to median, MEDIAN, and I'll say df here. Okay, so let's cross verify before applying the median. Let's cross verify the mean values which we have applied on the whatever we have applied. If we give here, if you see here, for the glucose column, right, or for the, you take the example of this skin fold. Okay, skin underscore fold, there are this null values NaN. So what is the mean of this column? If you do calculate it mathematically, df, this is my original column, dot mean, so the value is 28.93. Now if you take this df mean, okay, so skin fold, you see here 28.932, it has been rounded to 3 places of decimals. Okay, so similarly, each and every column we have applied the imputation, and we have using the strategy mean, and we have updated the null values, or filled the null values with the mean values. Now similarly, we'll apply this median imputation. Okay, df mean this, and now let's see what happens here. Okay, so with median also it happened the same. So let's take the median value is 29. So if we take this, now you see here, so if you see skin fold, in skin fold we have the third value, which is NaN, right? And if here you see, this is 29. After 23 and 35 we have again 29. So for this also it is being applied correctly. Now let's apply the modal values. Okay, impute with most frequent, because that's what is accepted in SimpleImputer. So before this, I'll give df underscore mode, strategy equals to most frequent, so here also, so similarly we'll get the mode of this column, which is 32. Now open this df mode, and you see this is applied 32, and this is here is also applied, and so the value is filled with the value 32. Okay, apply, we will fill the null values with constant values. Okay, so everywhere it will be filled with constant values. Suppose we give 48. Okay, just for an example. Okay, now if you see here what we are doing, we are creating a imputer object which is called constant, and where we are, our strategy is constant, and we are using the fill value as 48 to fill all the missing values in all the columns. Okay, we have constant. If you see here, this is 48, this is 48. Even in this we'll open the original data set. Okay, if you see here in the third dasteric BP, you see here in the record number 7, row number 7 here is 48, and here it is 48, 48, 48. This is NN, right? All the three values here, all three values is being filled with 48. So that's how our constant imputation works. Okay, so that's how our constant imputation work. Okay, say suppose there will be a scenario when each and every column will require a different strategy. Now if you see this, suppose this in this glucose column I want to apply the mean strategy, then in this diastolic BP I want to apply the median. In the skin fold I want to apply the mean median mode, followed by the serum insulin is it's something constant. Even in BMI is something I'll fill with constant value. So how do I apply imputation on each and every column differently? I don't want to apply the mass imputation strategy, like mean for all the columns, median for all the columns. There might be a scenario in which you have been asked to do this. So how do you achieve this? Impute different column with different strategy. So what I will do, I also see I have already created my objects, right? df mean, like mean imputer. I already have my mean imputer, right? My median imputer, my modal imputer, my constant imputer. Okay, so suppose we will use the same. We will apply the median imputation on this glucose column, mean on this glucose, median on this diastolic BP, modal on the skin fold, and constant fill. We will fill with the value 48, whatever. You can create one more object, it's up to you. But suppose I'm using the same. Okay, I will apply this constant imputer in serum insulin and BMI. So how do I do it separately? Not a tough, but a bit some work we have to do. So for this I'll just say df3 is equals to df dot copy. Okay, now if you see here, if you go pregnant will be the 0th column, like with the column with the 0th index, and glucose will be the column with first index. So I will say comma 1. Okay, and this will be mean underscore imputer dot fit underscore transform, and we need to only apply the mean on that specific column. We don't need to pass the entire data set. Okay, so in that case we will pass the specific column df3 underscore mean dot iloc. Now if you see this, okay, if you execute this, sorry, df3, only df3. Okay, let's first apply what happens if you execute this. Okay, exactly this will come. It will say that the data, reshape your data either using the array, because we are applying this. If you see the shape of this, okay, the shape of this will be 649 rows and there is no column. It should be one column. Okay, now if you give if you say that ds dot reshape -1 comma 1, then it will not work again. Why? Because you have to pass here the values. Okay, this is, so if you store this somewhere, it will show you, right, 649 rows and 1 columns. Okay, so we'll take this and we'll apply it here. So if you see now, df3 dot is null dot sum. See, glucose column, we have applied the mean imputation and it is gone. Okay, now we'll apply this, the median imputation on the second column, right? On this diastolic BP. So the null values are gone. Now we'll apply the most frequent on skin fold. So a skin fold is, the index of the skin fold column is 0, 1, 2, 3, 3, right? So we'll pass here 3. So, and if you apply that, if you execute that command now, it is being, now the only column that is left with null values is serum insulin and BMI. So we will apply the constant strategy. Okay, so we'll apply on both the column. Okay, the column is 4, 5, 0, 1, 2, 3. Serum insulin is 4 and BMI is 5, right? Now we will apply the constant imputer here. If when we apply the constant imputer, okay, the for serum insulin also we have applied it successfully. Similarly, we will apply it for the column number 5. And if you see here, so there are no null values remaining in your data set. So that's it, how we will apply imputation using the mean, median, mode strategy, a mean, median, mode and constant strategy, and we can remove the null values, the missing values, and even we can apply different strategy on different column and remove the null values. So that's it for the session. Thanks a lot for watching the session, and sorry for posting the videos after almost more than 2 months. Okay, I'm extremely sorry, and I'll be regularly posting my videos, and next videos will be related to missing number, where I'll show you the how to execute the package missing number package and visualize the missing values and furthermore. Okay, so I'll see you in the next video. Thank you.